guys, and welcome back to my YouTube channel. In today's tutorial, we'll be looking at high temperature detector system using a thermistor and LM324. In the previous tutorial, we looked at how you can actually use an op amp, and we also developed a shadow detector system that can detect shadow using the op amp and LDR sensor. So today we'll be looking at a high temperature detector system that will be able to detect a high temperature using the thermistor and the op amp. So let's hop over Proteus now and let's see how we can achieve this. So first of all, we're going to pick an NTC. Just in a nutshell, I will tell you what an NTC is. So let's pick an NTC, a resistor. Okay. We'll pick our favorite op amp LM324. We'll pick a battery. And we'll pick an LED. Alright, so let's take this. Okay, so this NTC is a thermistor. So what NTC stands for is negative temperature coefficient. So what it does is that this thermistor now acts like a resistor that has two terminals, okay? So what it does is whenever the temperature increases, the resistance of this resistor reduces. But when the temperature reduces, the resistance increases, just the same way that the LDR behaves. The temperature is inversely proportional to the resistance, okay? So that's what made it NTC, okay? So in order to use this man, we'll be converting this change in resistance to voltage by connecting a resistor in series with him this way, okay? And with our battery, drop this battery. I'm going to make the voltage 5 volts. Okay, then I'll connect this to this place. Then connect this to this place. All right, so, and then I'll be connecting a DC voltmeter here. And then taking it to ground. Now, let's simulate this circuit now. So you see that if I am increasing this temperature now, the voltage is increasing, okay? And if I am reducing this temperature, the voltage is doing what? Is reducing. So this is what we're actually going to make use of in this circuit. So let's take this man off. So let's introduce our op amp. Our op amp is here. And to use this op amp, you remember that once the voltage at the non-inverting input is higher than the voltage at the inverting input, the output is high. Okay, so we'll be needing a potentiometer here. We'll be needing a potentiometer that we're going to use to adjust the voltage that will be at the inverting input. So we'll connect this to the non-inverting input and the thermistor, the potentiometer to the inverting input. So we'll connect this to the positive and connect here to the negative. Remember to connect the positive of your op amp to positive and the negative to where? To negative. Okay, so let's connect a ground here. All right. So then to simulate this, I'm going to place a voltmeter here so that I can see the voltage coming out from our sensor circuit and a voltmeter here to see the voltage coming out from our potentiometer circuit. Okay. So let me not forget to add my LED at the output. So I'll connect my LED here. Good. All right. So at this point, the circuit connection is complete. So I'm going to simulate this circuit now. So on simulating this circuit, you can see that the output is low and the voltage at the non-inverting input is far higher than the voltage at the inverting input, okay? What I want is when this temperature now is above 30 degrees, I want this output to be high. So you see I'm having like 2 volts here. So I'm going to reduce this to go far below 2 volts. So let's say I have 1.9. Okay, let me just make it 1.85. So let's reduce this temperature now. Okay, so at around 28 degrees, it is low. But now, if the temperature increases to up to 30 degrees, I'm going to be having a high here. So you see that from this circuit now, I'll be able to get a high output here whenever the temperature is high. And whenever the temperature goes down to normal, the output will become low. So today, I'm not going to just leave this here. Let's think of how to integrate this to give you a stable device, a device that you can actually use in your home. You have a fan that whenever the temperature is hot, you want to go and turn on that fan. And whenever the temperature goes down, you want to go and turn off the fan. You can actually design a system that will turn on this fan on and off automatically for you without you going to the fan switch to turn it on or turn it off. So we are going to simulate that device here right now so you can actually understand how the device is working. And if you pick all the components we use here one after the other, I promise you are going to get the exact solution once you build the circuit. So I'm going to stop the simulation here now, and I'm going to be getting a DC fan. So this is a DC fan here. So getting this DC fan, I'll be needing a transistor. So let me pick BC547 transistor. BC547 transistor. I will equally be needing a relay. We've not used a relay in any of our circuits, so I'm going to introduce you to a relay. There's a component called a relay. So this is a relay. A relay is an electromechanical switch. Just like your manual switch that you go to turn on or off, a relay can either switch on or off by applying electronic signal here. So if you are used to your switch, you'll find out that you have S1, S2, and common. This pin is the common of the relay. And then this is the normally closed and this is the normally open. So we are going to be connecting our supply to the normally open and taking it from the common. So once we energize this relay, this switch now, this common will switch to the normally open, and then we'll be able to get our output. So that is how we are going to be using this relay here. So what we'll be doing now is I will remove this LED, and this relay now, because the signal coming from this LM324 cannot energize this relay, we'll be using a transistor to amplify that signal. So we'll be using the BC557 transistor. The transistor is not here. Okay, let me pick it. BC547 transistor, okay? Okay, I have it now. So I'll drop the transistor here. I'm going to be using a resistor at the base of the transistor, so I can reduce this resistor to 1K. Okay. So I'll be connecting the emitter to ground. That means what we are getting here is negative. So if I connect this here, my relay now needs a high for it to be energized. So if I'm using a 12 volts relay here now, that means my battery have to be 12 volts. So how do I power my system? We're going to be looking into that now. So I'm going to disconnect this and disconnect this, okay? Let me change this battery a little bit. So I'll make this battery 12 volts. I'll make this battery 12 volts. What we need here is a 5 volts. So I'm going to be picking a regulator called the 7805 regulator. And I'll be using this regulator. to reduce the voltage coming from this 12 volts, and I'll be giving my circuit a 5 volts. Don't forget to connect the ground. I'll connect it to ground. So with this now, I can comfortably take my 12 volts and connect it to my relay. So let me pick my DC fan. So this is my DC fan. So this DC fan also works with 12 volts. Okay. So once I give it positive and negative, then this fan will be energized. So I'll be taking the output from here and I'll be supplying a 12 volts to this normally open pin. Okay. I'll be supplying a 12 volts here. And I'll be connecting the other pin to ground. All right, so let's simulate this circuit now. But before then, let me explain what happens here. What happens here, once there is a high output here, this transistor will become biased. And because it is an NPN transistor, the base is positive. It's only a positive signal that can forward bias the base of this transistor. The emitter is connected to ground, and it will be able to give you a negative supply here, which is connected to one of the relay terminals, the relay coil terminal, and the second coil terminal is connected to plus 12 volts. So whenever we have 12 volts and ground here, this relay will become energized. So let me simulate this circuit. So as we can see here now, the voltage here is still smaller than the voltage here. So I'm going to increase the temperature now. So once the temperature gets to 30 degrees, you see that the fan starts rotating. Okay? And once the temperature goes down, the fan will stop rotating. Okay? Now, I want you to see what actually happens in this relay here. I want you to observe what happens in the relay here. Okay, so this relay switches on and off once there is a high output here. So watch how the relay will switch on now. You see the relay has actually switched on. The relay has actually switched on. And if I reduce this temperature, this relay will switch what? Off. So with this, we have developed a high temperature fan that can actually turn on your fan whenever there is high temperature and turn the fan off whenever the temperature goes low. So this is just a simple circuit that you can actually implement in your house just as a DIY. If you like the video so far, give us a thumbs up and subscribe to my YouTube channel because I have more content for you in electronics and embedded system at large. See you in the next tutorial.